This is SpaceTime Series 26, Episode 12. Coming up on SpaceTime, the James Webb Space Telescope sees clouds on Titan. The red planet Mars has curiously shaped sand dunes. And a spectacular late afternoon launch by the Falcon Heavy. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA's James Webb Space Telescope has turned its focus on the giant Saturnian moon Titan, finding fluffy clouds in its atmosphere. The discovery of Earth-like clouds adds to a growing list of similarities between the two worlds. Both Titan and Earth have a thick atmosphere. In fact, Titan is thought to have a primordial atmosphere very similar to the very early ancient Earth's atmosphere. And like Earth, Titan has rain, which wets the ground, forms streams and rivers, which then flow into lakes and seas. But unlike Earth's liquid water oceans, on Titan, the liquids are methane and ethane. You see, Titan is so cold, water is frozen solid there, forming bedrock. The new James Webb Space Telescope observations were combined with Earthbound telescopes to help astronomers understand the weather patterns on Titan in advance of a NASA mission to the moon called Dragonfly, which is slated to launch in 2027. Dragonfly will be a large multi-rotor autonomous lander designed to assess the habitability of Titan's unique environment, investigate the moon's unusual chemical stew, and search for signatures of water-based or hydrocarbon-based life. Astronomers have been observing Titan for decades, ever since before the Voyager encounter back in 1980. But over the past roughly 25 years, they've been focusing powerful ground-based and more lately orbital-based telescopes on the moon, complementing the observations of NASA's Cassini spacecraft mission to Saturn, which studied Titan between 2004 and 2017, and deployed the Huygens lander down to the surface, which, upon touchdown, described what it felt as cold, wet sand. When the James Webb Space Telescope team took their observations of Titan, they observed what appeared to be two large clouds in the moon's atmosphere. Follow-up observations using the high-resolution adaptive optics of the twin 10-meter Keck telescopes in Hawaii confirmed the clouds and helped track their movement across Titan's skies. A series of Keck images, taken about 30 and 54 hours later, showed similar clouds, likely the same ones, but slightly displaced because of the moon's rotation relative to the Earth. Although the quality of the Webb infrared and Keck optical images may look about the same, Webb has instruments that can measure aspects of Titan's atmosphere that Keck cannot. In particular, Webb's infrared spectroscopic capabilities allow it to pinpoint the altitudes of clouds and hazes with much greater accuracy. By using spectrometers on Webb, together with the optical image quality on Keck, astronomers are getting a complete picture of Titan's atmosphere, including the altitude of the clouds, the atmosphere's optical thickness, and the elevation of haze in the atmosphere. In particular, at wavelengths where Earth's atmosphere is opaque, that is, where Titan cannot be seen from any Earth-based telescope, Webb can still observe and provide information on the lower atmosphere and surface. NASA's Dragonfly principal investigator Z.B. Turtle from Johns Hopkins University says the observations were some of the most exciting data seen of Titan since the end of the Cassini-Huygens mission in 2017, and some of the best observations we'll get before Dragonfly arrives there in 2032. Which, when you think about it, is now just 9 years away. This is SpaceTime. Still to come, a study of the red planet's curiously sized sand dunes, and a spectacular late afternoon launch for the Falcon Heavy. All that and more still to come on SpaceTime. A new study has confirmed that the red planet's sand dunes, which dominate so much of the Martian landscape, form the way they do because of the red planet's thin, turbulent atmosphere. Among the mountainous dunes and small undulating ripples of Mars's desert-like surface are sandy dune-like structures intermediate in size, which aren't quite like anything seen on Earth. Now, scientists have used artificial intelligence models to analyze 1 million Martian sand dunes and finally uncover how these sandy waves are formed. They've found a precise and consistent mathematical relationship between atmospheric density and the size of wind-blown ripples and dunes on all but the smallest scales. The findings, reported in the journal Nature Communications, suggest that scientists could use fossilized versions of these same structures to reconstruct the early atmospheric history of Mars. One of the study's authors, Assistant Professor Matteo Laporte from Stanford University, says the discovery is especially important because it's thought Mars once had a thicker, warmer atmosphere similar to what's on Earth today. However, he says Mars somehow lost most of that atmosphere, turning the red planet into a freeze-dried desert, and scientists still don't know when, how fast, or why it happened. On Earth and Mars alike, wind-blown sand grains pile up in mounds of different shapes and sizes, ranging from dunes that can extend for kilometres down to tiny ridges barely a centimetre high. On Earth, the crests of these smaller ripples are typically spread a few centimetres apart. They're common in deserts and on beaches, and they're seen preserved like fingerprints of ancient winds in sandstone. Scientists call them impact ripples. That's because they result from wind-blown grains splashing into sand mounds like tiny torpedoes. In 2015, NASA's Mars Curiosity rover returned images of similar patterns on the surface of Mars. In addition to giant dunes, the images also showed smaller waves at two distinct scales. Some were similar in size to Earth's impact ripples, but others were about 10 times bigger, yet still smaller than Earth's sand dunes. And these look like they were shaped more by airflow than sand impacts. Exactly how these two distinct ripple scales came to coexist and co-evolve on Mars has been puzzling scientists ever since. One idea involved the middle-sized structures physically growing from the smaller impact ripples, enabled by the very low Martian air pressure. However, instead of there being a continuous gradual increase in size, there's an unexplainable absence of ripples with crests between roughly 20 and 80 centimetres apart. Laporte and colleagues think these shapes could be caused by hydrodynamic instability. That's already known to produce wind-blown dunes in deserts and similar undulating mounds in sandy riverbeds on Earth. Researchers have also speculated that the size of larger Martian ripples and dunes, as well as ripples which form underwater on Earth, could all be controlled by the same anomaly in the flow of air or water. These anomalies arise only after mounds grow beyond a certain size, and they would result from an interplay among different global atmospheric properties, like the density of the air, and local factors, like topography and wind shear velocity. But until now, scientists had only ever hypothesized the existence of these anomalies from tightly controlled experiments. It had simply not been observed in the complex environment of natural dunes. So the team decided to test out their idea by connecting ripple size to atmospheric density through statistical analysis using real data from the red planet. The authors used more than 130,000 high-resolution images of Mars captured by spacecraft and an AI-based computer model first developed to pick out different types of objects from a background by their shapes. They manually labeled the dunes in a small subset of images and then used those examples to train the AI model to detect dune contours and estimate dune sizes across most of the Martian surface. The authors then set about analysing this vast new data set along with calculations of atmospheric density across Mars. What they found was that the middle-sized dune waves were not impact ripples at all. Instead, the distinct structures on Mars are much more like miniature sand dunes that simply stop growing at a certain size because of anomalies in the airflow and the thin, turbulent Martian atmosphere close to the red planet's surface. However, the smaller dunes, just like the ripples, should decrease where the air is thicker. Meanwhile, the six-wheel car-sized Mars Curiosity rover is continuing its journey of exploration through the 154-kilometre wide Gale crater and up the side of its central peak, Mount Sharp. The 5.5-kilometre high mountain is like a geological layer cake of the local mineral composition. Each region represents a different period in the history of Mount Sharp, And Curiosity scientists want to visit all of these places to learn more about the history of water on the mountain, which slowly dried up as the climate changed. Understanding how these changes occurred on Mount Sharp may provide new insights into why water, one of the most critical resources for life as we know it, disappeared from Mars billions of years ago. This report from NASA TV.
NASA's Curiosity rover has been exploring Mars. The rover is climbing a mountain, Mount Sharp, that is dry and sandy today. But 3.5 billion years ago, rivers, lakes, and groundwater could be found here. Curiosity recently entered a valley between a ridge and cliffs higher up the mountain. We've been calling this area the clay unit because Mars orbiters have seen a strong clay signal here. That's exciting because clay minerals often form when water is around. From the ground, we can look for clues of ancient water. In these cliffs above the clay unit, the same orbiters see sulfate minerals. That could mean that water was drying up or becoming more acidic. Comparing the clay and sulfate layers could give us a better idea of how the Martian climate changed over time. Cutting through the sulfate layer is evidence of an ancient gushing river, Geddes Vallis Channel. In orbiter images, we've seen boulders and other debris that were probably washed out by the river. This channel formed after the clay and sulfate layers. It's a whole other chapter in the story of water on Mount Sharp. These features could teach us about more than just the mountain. They may help explain what changes were happening across Mars at the same time, and how that affected its ability to support life, if it ever existed here.
This is SpaceTime. Still to come, a spectacular afternoon launch for the Falcon Heavy, and later in the science report, an ancient Moab stele makes specific references to the biblical Jewish King David. All that and more still to come on SpaceTime. SpaceX has successfully launched its fifth Falcon Heavy rocket in a spectacular sunset launch from Cape Canaveral in Florida. The massive Falcon Heavy, made up of 3 Falcon 9 boosters mounted side by side, lifted off from Pad 39A at the Kennedy Space Center, carrying the U.S. Space Force 67 mission. Producing a massive 5.1 million pounds of thrust, the Falcon Heavy is second only to NASA's SLS Space Launch System in terms of the most powerful rocket currently flying. In fact, it can carry up to nearly 30 tons to geostationary orbit, which was the target of this mission.
Next up will be Falcon Heavy in startup, and that will be at the T-1 minute mark. That's where the internal flight computers take over the launch countdown.
Falcon Heavy is in startup.
We're now just waiting for the final call from the launch director.
This is the mission director. Go for launch.
And excellent news. All systems are go for launch of Falcon Heavy with USSF 67.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Engine full power. And liftoff of USSF 67. Go Falcon Heavy. Go Space Force. Booster chamber pressures are nominal.
T plus 40 seconds into flight under the power of 5 million pounds of thrust.
Power and telemetry nominal.
Falcon Heavy is headed to space. Now we did throttle down the engines around the T plus 40 second
Vehicle
mark
supersonic.
in preparation for max Q.
Max Q.
And great call out there that we have passed through max Q. That's the largest mechanical stress on the vehicle on ascent. Falcon Heavy in flight. Now next events coming up will be booster engine cutoff, or BECO, followed by separation of the side boosters and followed by their side booster boost back burns. And then will be center core main engine cutoff, or what we call MECO. Again, those events coming up here just under a minute away. That will be BECO. That's where the side boosters engines will shut down. The center core will push those side boosters away from the vehicle. Then those 2 side boosters can begin to make their way back down to Earth with their boost back burns.
Side booster separation.
Side core booster startup.
We just had BECO and separation of the side boosters. The side boosters have lit back up. They are now in their boost back burn, making their way back down to Earth. Now, those side boosters are returning to Florida under the power of 3 engines. That's 3 of the 9 M1D engines. Next up will be the conclusion of those side booster boost back burns, followed by MECO on the center core, as well as stage separation of the center core and the second stage, and then SES-1 or second stage engine start 1. Now, as I mentioned previously, per the request of our customer, we won't be showing second stage views after SES-1. And additionally, our center core or stage 1 is expendable today, so we will not be attempting to recover that vehicle.
Side core, boost back, shut down. MECO. Stage separation confirmed. MVAC startup.
And we had the
Stage 1 FTS has safed.
We did have the shutdown of the boost back burn. We did have the shutdown of the boost back burns on the side boosters, as well as MECO on that center core and stage separation. We are waiting for confirmation of a call out of the fairing separation.
All vehicles are following nominal trajectories.
So currently stage 2 is still making its way to its targeted drop-off orbit, while the side boosters are making their way back down to land. Again, these side boosters have another burn coming up. That will be the entry burn. That will be 3 of 9 M1D engines reigniting. That helps to slow the boosters down in preparation or as they re-enter the Earth's atmosphere. Now, at the time of separation, the side boosters were traveling slow enough to turn around and make their way back to land, to our side-by-side landing pads. If we have successful landings today, we'll mark the 163rd and 164th landing of an orbital-class rocket. As I mentioned earlier, the center core will be expendable, and we are not attempting to recover it today.
Side core entry burn startup.
The entry burns for these side boosters have begun. They're just about 12 seconds long.
PY FTS has saved, and NY FTS has saved.
And the entry burns for both side boosters have now concluded. Now, next up will be the final burn for each of these side boosters. That is the landing burn. It is just a single engine burn, the center E9 engine. Each one of these M1D engines have about 190,000 pounds of thrust. So that is enough to slow the vehicle down just in time for landing.
Side boosters are transonic.
Now, that landing burn coming up here in just about 20 seconds or so. Landing burn will last about 20 seconds long. Again, we are scheduled to land on landing zone 1 and landing zone 2.
Landing burn.
And there are those landing burns have begun on the side boosters as they touch down.
Stage 2 is on terminal guidance. Stage 2 FTS is saved. Booster landing leg deploy.
What an incredible sight to see as we watch the side boosters touch down for landing. That confirms successful landing of both Falcon Heavy side boosters on landing zone 1 and landing zone 2. Now, with these 2 side boosters, this marks the 163rd and 164th overall successful landing of an orbital class rocket. It's also the 25th landing on landing zone 1 and the 6th landing on landing zone 2. And with successful confirmation of our side boosters landing, that will bring today's webcast to a close.
The payload included Space Force's second continuous broadcasting augmentation SATCOM communications satellite, the first of which was launched back in 2018 on a United Launch Alliance Atlas V. Also aboard was the long-duration propulsive ESPA-3A rideshare spacecraft, a sort of space tug that can carry up to 6 spacecraft in what Space Force officials like to describe as a freight train to space. The payload included 5 satellites, Space Systems Command Catcher and Wasat spacecraft, and 3 payloads for the Space Rapid Capabilities Office, including 2 operational prototypes for enhanced situational awareness and a crypto interface encryption payload for secure space-to-ground communications. The flight was the second national security space launch for the Falcon Heavy, which set up the US Space Force 44 mission in November. SpaceX has 4 more Falcon Heavy missions on the books for 2023, including another Space Force mission, dubbed 52, which is expected to fly in the next few months. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. Scientists are warning that a new coronavirus subvariant called XBB.1.5 is now on the rise globally. A report in the journal Nature says it's now responsible for 70% of SARS-CoV-2 cases across the northeastern United States, and it will almost certainly soon dominate globally. The variant might not cause big waves of illness thanks to pre-existing immunity, vaccination and boosters, but researchers are still tracking the lineage closely as it has a rarely seen mutation that makes it more infectious, which therefore creates an opportunity for more evolutionary gains. Over 6.8 million people have now been killed by the COVID-19 coronavirus since it was first detected near China's Wuhan Institute of Virology around September 2019. But the World Health Organization warns that the true death toll is more likely to be around 16 million, with at least 672 million confirmed cases globally. A new study warns that ecosystems in Western Victoria and the west coast of Tasmania may be the most at risk from climate change in coming decades. The findings, reported in the journal Nature Ecology and Evolution, compared the traits of plants currently growing in southeastern Australia to species that have existed in the region over the past 12,000 years. Many of these ecosystems are already facing habitat loss and species extinction. The authors found that up until around 6,000 years ago, plants in southeastern Australia were more functionally diverse with more productive growth strategies. But drier, unstable conditions over the past 4,000 years have triggered a marked change in plant function in some of these areas' ecosystems, including in Western Tasmania's World Heritage Rainforest. The plants in these areas tended towards less productive growth strategies or mechanisms to reproduce and survive in a harsh landscape. And the researchers warned that this trend's likely to continue under the more frequent droughts expected over coming decades. Archaeologists have successfully translated the Misha stele, finding that the inscription contains specific references to the biblical Jewish King David. Originally discovered in fragments in 1868, the famous stele is now on display at the Louvre Museum in Paris. It's a large slab of basaltic rock etched with a lengthy account of King Misha of Moab going to war with Israel. The events described correspond to a similar account in the Old Testament's 2 Kings chapter 3. The text, which is written in Moabite, refers to the Israelites' God as well as the house of David and the altar of David. Until now, scholars weren't sure if the references to the biblical King David were being correctly deciphered. But now scientists at the University of Southern California have used what's called reflectance transformation imaging to take multiple digital images of the artifact as well as images of an original impression of it from different angles, all of which were then combined to create a very precise three-dimensional digital rendering of the slab. This allowed the archaeologists to control the lighting of the inscribed artifact so that hidden, faint or worn incisions would become visible. And when these new high-resolution images were projected onto the original 150-year-old impression of the stele, scientists were able to glean a much clearer picture of the ancient inscription, confirming the Moabite phrase, House of David. Okay, time now for the silliest story of the week. What do Albert Einstein, Isaac Newton, Leonardo da Vinci, Plato and Socrates all have in common? Well, they're all extraterrestrials from another planet, of course. Or at least that's the conclusion of paranormal expert, the Reverend Lionel Fanthorpe. For most of his adult life, the Reverend Fanthorpe has been delving into the great mysteries of the world. Along with his wife of 62 years, Patricia, the duo have written hundreds of books and investigated countless seemingly unexplainable cases of strange phenomena and the paranormal. Tim Mendham from Australian Skeptics says exorcisms, time travel and ghostly goings-on are all in a day's work for the good Reverend.
This is a story of paranormal expert, aren't they all? The Reverend Lionel Fanthorpe, who's convinced that there is a multiverse and that basically the human race has been created, or some members of it have been created by aliens, and that includes Einstein and Da Vinci and other people that he classes as geniuses, whether it was Plato or Socrates. What it's saying saying is that smart people can only come from elsewhere, and that we can only produce non-smart people here on Earth. So we're pretty pathetic, and we need the outside people. And of course, the thing about the Reverend Fansthorpe is that he's been around. He has been a reverend for 2 different churches, including the Universal Life Church. He's an entertainer, a dental technician, a journalist, teacher, TV presenter, author, lecturer, industrial trainer, warehouseman, and a van driver.
So he has all the right credentials.
He has all the right credentials to recognise an alien genius when he meets one. It's a silly story, and it's wonderful for that reason. Always like a silly story, but there's no reason to believe him at all.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.